we're going to try to make this as much like what we have done already as much, okay? So these problems, they look horrible. Yeah, so, no, you're good. So if you can factor on these, okay, factoring is crucial in this, not just 5.1, but pretty much throughout Module 5 here. At least if you can factor, you have a good head start. If you cannot factor, you need to go back to Module 4 and review until you do feel comfortable factoring, because if you can't, this stuff is not going to do you, the lesson pretty much isn't going to do you any good. We're still going to factor. I'm still going to show you how to factor by grouping.
Factor, we're kind of
yeah.
out of luck.
Yeah, if you can't factor, this isn't going to do you, this lesson will do you no good. Right here we got, this is just examples, right? I mean, I see maybe one of those, maybe, not even one that I could factor. No, one of them I could. Maybe a couple. But it says we got rational expressions, okay? So this is the most common one that you may be familiar with. Others of this type, like 1/2 or 3/4. These are rational expressions. Fractions are rational expressions. So rational just means that you could take a number and change it into a fraction. So the number 8 would be a fraction, or I'm sorry, be rational because you can change it into a fraction of 8/1, fraction. Okay, so you see all these actually are fractions. That's what this is saying. You got a rational expression, you can make a fraction out of it. It's just sometimes they don't look like this. Sometimes you got some letters, some variables in your fraction. Sometimes you got, well, I guess a couple of variables. You could have more than this though, all right? And then, well, what do you do? Because, for example, we've seen fractions before, like 1/2, it's possible you could write it as 2/4 or 3/6 and so forth, okay? This pattern can continue forever. But of all of those fractions, 1/2 would be considered the most simplified. Okay, so when we see these fractions or rational expressions, we need to be able to simplify them, and that's where that factoring stuff comes into play. Functions, just functions as fractions, because it's got the word rational in it, which is just kind of a math way to say fraction. And well, in the past we know fractions themselves, just regular fractions, they can destroy people's lives. But now when we see these types, I mean, it's destroyed before you even get started sometimes, okay? But don't be intimidated by this. Even this one right here, we could simplify that. I think we will eventually, but keep that in mind. Don't worry about the whole fraction right here. Focus on one part at a time, factor that out, and then go back and see what it looks like as a factored fraction. Because once it's factored, you may notice some things. So we can say, yeah, so we're simplifying these rational expressions. Just remember that anything divided by itself is 1, yeah, by factoring the numerator and denominator and removing factors of 1. So it says factors of 1. So we're going to make these phantom ones. So remember, let's say that I had 1/2. Okay, so we're going to go something pretty familiar, but I wanted a new fraction. So what I could do with 1/2 is and this goes way back, but you could say, you know what, I want a denominator of 6 right here. Well, how did you get that? Well, you'd have to take 2 times 3 to get the 6, but in order for the fraction to be an equivalent fraction, which is important, that's what the equal sign is right there, you'd have to multiply the numerator by the same thing, 3, and then you'd get 3/6. Okay? Now, what this means as well, so I'm going to use it, that was an example right there of, this is scaling it up, but finding an equivalent fraction. But if you start with something that can be simplified, so there's a new example, I guess let's go with 12/16. Okay, so you'll see that this is actually pretty familiar. What you could do, and I'm purposely relating this to prime factorization, okay, for the purpose of the rational expressions. I think some of you could do this in your head. You're like, I could simplify that in my head, and that's great. But again, I'm doing it with prime factorization because it's related to the rational expression stuff. So 12 would have been 2 times 2 times 3. 16 would have been 2 times 2 times 2 times 2, like this, okay? Now it says up here, you can remove factors of 1. Essentially, we're making these phantom 1s, right? So in other words, 2 divided by 2 is 1, and that's a 1. I didn't just cross it out. I crossed it out with a 1, so I know I can make that a phantom 1, right? And same with this 2 divided by 2. It's just a different color, but it's a 1. And then if I wanted to, I could rewrite the fraction. I'm purposely keeping these prime factors separated. In the numerator, you had a 3 left over. In the denominator, you had a 2 times 2 left over, okay? So you've seen this before, hopefully. Maybe not very recently, but you've seen it before. And just keep in mind that sometimes you can factor these out. Instead of these being 2s, let's change this. What you could see is that maybe it's a binomial, okay? So for example, you could have had 2 times, let's do x minus 9, and then it could have been over just x minus 9, right? Well, anything divided by itself is 1, which we've seen. So I could say x minus 9 divided by x minus 9. I can cross that out with a 1 and then ignore it, and then what's the simplified form here? It's 2. All right? So now, instead of just getting rid of these as phantom 1s, we can get rid of binomials and trinomials and things. If they match, we can get rid of them like that. So if you can understand that, again, you do have to get to the factoring point, right? Like, this won't come like this usually. It may start out like this just to help us get started. But usually you have to force it to be factored, and then you'll notice, oh, there's a x minus 9 in the numerator and denominator. Boom. I can get rid of that garbage. Hopefully when you do, you feel good about it. We've seen domain, right? Now, since we're looking at fractions, we know that the denominators cannot be 0. So yeah, denominator. Whenever you see denominators, it's going to say, or these rational functions. Just remember the denominator can be 0. So this goes back to what we saw, what was that last night, 4.8, 4.7? At the denominator here. I remember with these, and we've seen these before, I don't really care about the numerator. Even if I can get rid of stuff with phantom 1s. Just remember, if you saw something like this, so let's do that x minus 9. Let's see, add another one even, like a x plus 5 right here. So maybe you started with the trinomial that produced this as a factored 2 binomials right there. Then you'd have to know, and of course this would come with some work, that x could not equal 9 or negative 5. Because if it did, it would make the denominator, if you replace this x with 9, you'd have 0 times 14, but you'd get 0. And you can't get that. You can't get zeros in denominators. So that, again, that's a pretty direct relation to what we saw last night in whatever it was, 4.8. And then also if you replaced x with negative 5, you'd get a 0 here. You'd have negative 14 times 0, which is still 0. You can't have that. So we know, and we can declare this as part of the domain. Just don't make x 9 or negative 5. We can do that with an interval notation. We can do it with kind of a direct inequality statement like this. Depends on how they want it on the assignment, but they're going to want it, okay? So you can't have denominators that are zeros. And then let's just tack this on again. So let's say there was even an x out there. Then x couldn't be 9, negative 5, or even 0 on this, which could happen, okay? So don't make those, don't let your denominators be zeros. But again, if you are struggling to solve those equations from 4.8 or whatever it was, then you may have to go back and study that stuff a little bit more, okay? All right, find the domain of f, that's f of x, and write your answer in interval notation. So this one, we're not looking to get rid of the phantom 1s. It's just asking for the domain. Well, it's a fraction, so the whole numerator up here, I don't really care about it. I don't care what's there. I don't care if it can be factored. I don't care if it can be taken away as a phantom 1. I don't care about that. All I care about is the denominator, which shows is x squared minus 9x plus 14, okay? So I need to see what this is factored, right, so that I can figure out what not to make 0. Okay, so my leading coefficient is 1, so I'm going to take 14 and split it up. It looks like, so I'm going to skip some of the extra pairs here, but it looks like it should be -7 times -2. -7 times -2 is 14, but -7 plus 2 is -9. Of course, there's other factor pairs, right? You got 1 and 14, you got 7 and 2, you got -1 and -14. None of those matter. It's this one. This is the one that we want so that we can make this then factored, right? So I'm just taking a shortcut. I'm not going to factor by grouping here. I got x minus 7 and x minus 2. Now this is, if you wanted to, you could say then that the new fraction, again, I don't really care about the denominator. I'm sorry, I don't care about the numerator, but the denominator now is x minus 7 and also x minus 2, okay? Again, I don't care about the numerator. Why do I only care about the denominator? Because it's asking for the domain, so I need to know what x cannot be. Well, if I were to do that, then I would have to make sure that this, even as a full equation, cannot equal 0. Okay, so but it goes back to what we did in 4.8. So it would say, look at this x minus 7 business, okay? If it were to equal to 0, it would make my full denominator equal to 0. I can't have that. I don't want it. So I've got to make sure that this does not equal 0. So I'm going to solve it just like I would an equation, though, by adding 7 to both sides. And then I see that x, because that zeroes out, could not equal positive 7. So that's part of my, that's one of the main values I need to remember in my domain, which we'll get to interval notation. But then in addition to that, the other binomial, x minus 2, I need to make sure it cannot equal 0 as well. So again, solving this like an equation, I would add 2 to both sides. That zeroes out. X then, it cannot equal 2. Now there's going to be problems where it says, hey, just tell me what numbers it can't be, and that would be great. But this one, it says it wants interval notation, okay? So I'm going to take this, and then, I like to see interval notation with a, number line right here. So that'd be 0, 2, and 7. Again, I just like to see where 0 would be. So what happens here? Well, I know that x can't be 7, so I got an open circle at 7. I know x cannot be 2, so I got an open circle at 2. There's no other restrictions on the domain. You could have any other fraction, any other number, any other integer, anything else works. So, no, you're good. So that means everything to the left of 2 would work. It means everything between 2 and 7 would work. And it means everything to the right of 7 also would work. So we need to show this interval notation, but to exclude 2 and 7, right? So I'm going to start, I always start myself to the left. So I know that that line in orange goes all the way to negative infinity, rather.
Oh.
Then there you go. So it stops at 2, which is not included, so I've got a parentheses there. And then I'm going to start back up. So I'm going to unite this at 2, but again, it can't be included. And then that is going to go all the way to 7, which also cannot be included. And then I'm going to unite that with this other orange line going to infinity, but that would start at 7, not included still, but then it goes to infinity, which also is not included.
Is that the first time we're seeing it?
So we have seen examples with just the one u, but now we're looking at a 3-part union on this, okay, with the interval here at the bottom. All right, this one's nice. We don't need interval notation. It just says, hey, please tell us what can't be included in the domain. State the excluded values from the domain. It's going to have this type of wording on the assignment. Expect it, okay? Now, remember, though, since I'm looking for exclusions in the domain, I don't care about the numerator. So even though possibly that could be factored, possibly not, I don't care if it can be, because I'm just looking for the domain, all right? So on this one, I would look at just the denominator, which is x cubed plus 7x squared plus 10x. And then I look to factor it. Now, on the last example, we saw that the leading coefficient was a phantom 1. Now, well, it still is, by the way. But I noticed that I have x's in all 3 of the terms. So I know also that I should be able to take out an x from all 3 of the terms. Okay, so what am I left with then? The first term, I took out one of the x's, so now I've got x to the power of 2. The next term, I had x to the power of 2, so I'm just left with the x. We didn't do anything with the positive 7. And then the final term, we took out its x, so we're just left with the 10. All right, so I yanked out an x. Okay, now what does that mean? We'll get to it. We'll get to it. And I think we've seen it a little bit a couple slides ago. But here now, I see that my leading coefficient is 1, and so I should be able to just take this and split it up into two binomials without having to go through factoring by grouping. But if you need factoring by grouping, always do it. It's a legitimate way to do things, even at this point, okay? So, since I have leading coefficient of 1, I've got x's, but then I have to ask myself, what two factors of 10 would add up to 7? Yep. Why did 2 times 5? But it doesn't matter which order you put them in. Sorry, they had them written, but yeah, we got a positive 2 and a positive 5, and yeah, the order doesn't matter right there. Okay, so we did factor out the denominator. Okay, so again, you could have rewritten this fraction. Again, I don't really care about the numerator, but then you could have written it like this. And sometimes just seeing it like this is like, wow, that is freaking awesome. Look what I did. And you want to post that on the fridge. But it's not done yet, okay? Don't be finished yet. You got to make sure that this denominator does not equal 0, right? The good news is we just want excluded values. But we got three, we kind of have three polynomials here. We got this monomial right here, the x. We got the binomial x plus 2, and then this binomial x plus 5. I know not everyone needs all this extra work that I'm going to do to solve them, but I'm still going to, okay? So the first up, I'm going to start with the x. I know that x in red, I just can't make it equal to 0. That's it. I don't need to solve that as an equation. It's done. It's just x equals something or doesn't equal something in this case. But then I've got the binomial x plus 2. I need to make sure that couldn't equal 0, because if it did, it would make the whole denominator 0, which we don't want. So I'm going to subtract 2 from both sides, zeroing that out. Then my x, I know, could not equal negative 2. And then finally, I've got this last one, x plus 5. I need to make sure it could not equal 0. So, I should use a different color there. Not just because it's pretty, but just to separate the work there. So minus 5 from both sides. So now x could not, because that zeroes out, x could not equal negative 5. So I believe on the assignment it's going to have something like this. It's going to say x cannot equal, then it's going to have a box that you fill in. All right, just list your values, and I believe it doesn't matter what order they're in. You got 0, it cannot equal 0, negative 2, or negative 5. So I went from greatest to leastest. You could go from leastest to greatest, or you could make it randomized if you really want to feel like you want to do that, because it doesn't matter. But
And is that how we'd enter it in the homework?
I think this is just, you just have a box to put just these values in.
Okay.
You wouldn't need to do the x doesn't equal. All right, now we're getting into the simplification, right? You have to be able to factor. You have to be able to factor these, not just the binomial in the numerator, but the trinomial in the denominator. It's not asking about the domain though. So do your domain stuff. Those are different problems. You're gonna have to do it though. This one, we could still declare the domain, which maybe I'll do just kind of quickly at the end. But we need to be able to factor these, okay? So don't get caught up in the full fraction, which is usually what destroys people's lives about fractions. Focus on just one part of the fraction at a time, numerator or denominator first. I tend to focus on just the numerator first. So when I do these, I'm going to do the numerator, then the denominator. Some students are like, I really want to do the denominator. Go ahead. You're going to get the same stuff I am, I hope, anyways, okay? So on this one, well, it is beneficial to have all the factoring stuff memorized, but I'm going to do the work below because I don't have any space above. But 4x squared minus 9, right? This looks to me like the 4 and the 9 are perfect squares. They are. They are. The reason why I'm pointing that out is because I now am looking at a difference of squares. And so what does this mean? Well,
we can ignore the top.
yeah, since I'm simplifying now I do need to focus on that numerator. Yeah, thank you. So I see right here that my first term in it, and it's subtraction, right? So I am expecting this to break up into two separate binomials, one with subtraction, one with addition. But I see that the 4x squared, it would have been a 2x squared, and then the 9 would have been a 3 squared, right? So I now have 2x squared minus 3, but also 2x squared plus 3. All right, and that is my, oh, not the squared, I apologize. I put too much in there. 2x minus 3 times 2x plus 3. That is my factored numerator. So again, that's why I kind of like to focus on just one part at a time. My numerator now is showing as 2x minus 3, and then also 2x plus 3. That's my numerator. Well, what the crap does that mean? You just factored the 4x squared minus 9. That's true. But I don't care about what's going to happen. Maybe nothing happens after that. But in order for us to know that something's going to happen, we now have to look at the denominator, 4x squared plus 12x plus 9, and see if this can also be factored. And it can. That's great news. Because I see the 4x squared, again, that would have, well, I suppose not so surprisingly, but that would have been like 2x to the power of 2, and then 9 is a 3 to the power of 2. So this is going to, it looks like going to be a perfect square trinomial. But we got to check, right? The 12x is that 2 times the a, which was 2x, times the c, which was 3. 2 times 2 times 3, yeah, that would have been a 12x. So this is going to work. It's going to be 1, well, we usually would write it like this, right? And I see the plus sign right there, so I'm expecting a plus between the two values of 2x and 3. It's likely that you're going to want to see this not with an exponent, meaning that you're going to want to expand it from the exponent. So that'd be 2x plus 3. I can do better 3 most of the time, but twice, right? Multiplied by itself. So now that's as much as I can see that I can factor that denominator. So I'm going to go back up here and going to write it in my actual fraction. So I got 2x plus 3, and then times 2x plus 3. And hopefully we notice, so at this point, okay, this is new to us. Let's just sit back, relax a little bit, look at what we've done. We can feel good about it. We've done it correctly. If you've done it with factoring by grouping, you've done more work, and hopefully that makes you feel good inside. But math usually doesn't. So we look at this and we see, all right, well, what do we do with this now? Well, like I said, we look for anything that we can divide by itself. It's just, it's not kind of like what we're used to with the fraction stuff. Because now the factors that we're going to be taking out as phantom ones are binomials. For example, right here I have this 2x plus 3 in red, and I'm going to pair it up with the one directly beneath it, 2x plus 3. That means that, and you could separate it if you really wanted to, but that's a lot more writing, I hope, than anyone really wants to do. It's 1. Okay, now that green one that I just put in there, I'm going to make it a phantom one. What the crap you mean, Sal? It means that I'm going to take the other two binomials, so I still had the 2x minus 3 in the numerator. And in the denominator, I had the 2x plus 3, the other 2x plus 3, I should say. Now, I could show this as times by 1 right there. I just don't want to, because that would make me feel icky inside being a math nerd, okay? So we look at this and say, oh, I feel even better than I did before, even if I used factoring by grouping. And yes, I'm putting words into your mouth, but we look at these two and we say, can I factor these out anymore? We cannot. It is done. Now, of course, we would ask, it's possible it may say something like, well, what about the domain? Well, we know, and I'm skipping some steps here, x could not equal a negative 3/2, not just once, but twice. So that's the domain. I also assume you don't care, but eventually I suppose it may ask not just for the simplified expression, but also for the domain, which we've done. So this is a common error that we see on tests and assignments and quizzes. Not that we have quizzes here, but some students say, look at my 2x's right there. Those, I can simplify those, right? I could say, look, I'm just going to make these a phantom 1. You cannot, because they're part of a binomial together. In fact, I took away the parentheses just because it makes it look pretty to me, but if it helps to see it like this, you can only simplify factors not individual terms by themselves. Now, I suppose there are ways you could do it, but I'm not going to show it because it wouldn't help. It actually would not be able to simplify still. So yes, do not simplify those two x's. This is the final answer right there. Or even that some students say, well, the 3's even, I could simplify those. No, yeah, you can't do that. Well, hopefully that last problem gave you a lot of confidence instead of destroying it, which is what it usually does. But multiplying rational expressions. This, by the way, it's rational, which is just fraction multiplication. That's all this is. Don't let all the wording confuse you. It's just fraction multiplication. Oh, I thought it was going to end. There we go. It's just fraction multiplication. So remember in the past when you've done this, so it says completely factor each numerator and denominator. Show the numerators and denominators. What the heck? We'll do 20 divided by, well, 25 for now. I just want to keep it back to what you guys have done before. But let's say that was multiplied by something like 1/2. What the heck? We'll do 1/4. Okay. Well, in the past, they would say something like, hey, go ahead and take these and split them up into their prime factors. So 20, for example, here would have been 2 times 2 times 5. 25 would have been 5 times 5. And then the 4 would have been 2 times 2. The 1 is kind of fully factored already. And then what they would say is go ahead and take these, and what we're going to do is we're going to find matches in the numerator and denominator. So I see this 5. Why am I starting with 5? I don't know. I just kind of did. And this 5, they match. I cross those out separately because sometimes they're not always above and below each other like we saw in that last example, the binomials, right? So we say we're crossing these out, but it's just a slanted 1 because we can ignore ones that are being multiplied. I'll put 2 slashes through that. It's just so you can see I'm pairing this red 2 with this green 2. That's it. Okay, but it's still a 1. And same with this other 2. I can pair it with this other 2 in the denominator, right? Oh, that's nice. But what are we left with? Well, I'm left with 1/5. Okay, because I didn't have another 5 to pair this other 5 with. And so this is as simplified as I can make it. It's just now we're not going to see numbers by themselves most of the time. Sometimes we can with greatest common factors, but we're going to see these, instead of a 2, you're going to see an x minus 3, and then down here is an x minus 3. Cross it out because it goes away as a phantom 1. All right, same with sometimes they are pretty close to each other, above and below each other, so you can see this one would be like 5 plus x, and this one's 5 plus x. Cross those out because you can. They become phantom 1s, all right? And then you'll get something simplified, something it won't look quite like this. But you'll have more fun doing it because you get to do it more in a different way. But yeah, that's what it's saying. Factor everything first. Factor your trinomials, your binomials, if you can. Factor them as much as possible. And then, yeah, you may have to re-show this. Again, I'm relating this to prime factorization because it does relate pretty directly here, even though not everyone would need that, right? Some people would just do cross simplification. That's fine. And then, of course, you find anything that can be any matches in the numerator and denominator that can go away as phantom 1s. Wanted to mention was that when you do fraction multiplication, it's just one fraction multiplied by the other fraction. That's it. You could put a multiplication symbol between, but it doesn't really change anything in terms of where you can pair things, numerators and denominators. Like this red 2 that I paired with this green 2, they're not even from the same fraction, but because they were multiplied, doesn't matter. So yeah, so we've seen this already with the last example. You can simplify things if you factor your binomials, trinomials, and you get some of the same factors in the numerators and denominators. The way I was just showing that, right, is we just kind of cross this out as a phantom 1. That was better. Okay, so that 1 right there in green, it's this 1 right here. But in the end, it's there, by the way. The multiplied by 1, it's still there. In fact, there's many multiplies by 1. They're just phantom 1s. I don't want to look at that garbage, so I'm not going to. So as simplified, right? Something times something, if you get something times the same thing from the numerator and denominator there, just ignore those things that match. You end up with whatever's left over, whatever is left over. Okay, so don't get overwhelmed. We're going to do this in 4 separate parts. How do you know it's 4 separate parts? Because there's 4 total parts to these fractions. You got 2 numerators, 2 denominators. I'm going to separate them and focus on them separately, okay? So we'll still come back to it, by the way, so I'm going to need some space there. In fact, I may need some extra space. Let's see, that's not what I want. Okay, so let's take this numerator here. And I'm gonna that's just from the numerator. I'm gonna do this part in red so that we know which parts are which. And let's factor this sucker. Okay, now my leading coefficient is a 1. That's convenient because I'm just gonna hold on, it's technology. Working now. So I'm expecting, all right, my 2 binomials, we're going to take the 2 and split it up into the factors of 2 times 1, which is 2, but also 2 plus 1 is 3, and so I know that my 2 binomials will be x plus 2 and also x plus 1. Now, if you don't have that memorized, because it was kind of a long time ago, and we didn't see too much of it in 4.7, or even, I think, 4.6, but you may have to do factoring by grouping until you can see that pattern and then notice that you can take that trinomial and split it up that way. So going back, let's go back to the top here, right? I'm gonna factor these out, but I'm gonna end up with 2 fractions, right? Well, I just got that first numerator on the left as x plus 2, and then also x plus 1. So, by the way, for you nerds that are like, I really love this factoring stuff, look how many times you get to do it right here. You're going to have so much fun doing it. For those of you that hate it, hopefully we'll give you enough experience and then brainwash you into liking it. Well, not really, but in any case, I'm going to go to the denominator next. Okay, so that same denominator. All right, there we go. I got that set up. So this one I'll do in purple. So this part, right? Oh, okay, so this one, the leading coefficient is 1. It's a trinomial, so again, I'm expecting this to be just 2 binomials. We're going to have x's as the first term there, but I need 2 factors. This is -8. I need 2 factors of -8 that add up to -2. I'm going to use -4 and +2, okay? So again, the first factor there, -4, I'll put into the first binomial, and then the +2 goes in the second one, okay? So that's completely factored. And now I can put that into the denominator of that fraction. So I have it written as x minus 4 and then x plus 2. And just real quick, I set it up as x minus 4 and then x plus 2. Some students like to switch these just so the x plus 2s are above and below each other. It doesn't matter. You're going to get the same thing. You can they become phantom 1s one way or the other, okay? All right, next up, I'm going to go to the numerator of the second fraction. This will let me do it. There we go. Okay, and I look. So these 2 I didn't focus on any greatest common factors because I didn't see any of the 3 terms that had x's. And I didn't see, and then the leading coefficient was 1. This one though, it's a binomial. If this x was squared, I'd be looking at maybe the difference of squares, but 5 is not a perfect square. So I should be looking right now at something that's a greatest common factor. I'll do this one in green. So I'm going to factor out from here, from 5 and 20, I know I can factor out a 5. So the first term, I factored out the 5, I'm left with the x. We'll keep the minus. It's really -20 divided by 5, though, which is -4. Okay, so that's my numerator of the second fraction. I've got 5, parentheses, x minus 4. Now, before I continue, I'm getting a little bit ahead of myself here, but the x minus 4 in green and the x minus 4 in purple, that means something. I'm going to wait to get to it as much as you want me to get to it right now or never. So I'm going to go now to the denominator of that fraction. I'll do this one in orange. It's a binomial with a leading coefficient that's 1. So I'm looking just to find 2 factors of -5 here. that add up also to -4. From what I can tell, that should be -5 and +1. So that's going to be x minus 5 and also x plus 1. Okay, so that was the denominator of that second fraction. Let's get that in there. X minus 5 and then also x plus 1. All right, so you can see, you math nerds that are like, I love factoring, you just had a grand old time right there. But it's not done. It's not done for those of you that are like, I wish it was done. We're pretty close, though. We're pretty close, okay? So we're just looking for matches in the numerators and denominators. We don't care where they are, as long as they match. But it has to be numerator and denominator. Some students are like, well, if they match in the numerators, then I can cross those out. No, because it has to be something divided by itself, okay? So I see my x plus 2 there. There's an x plus 2. Again, those are slanted ones just to show that we are crossing them out, but I'm going to make those go away eventually, right? Then I notice the x plus 1 and this x plus 1. We got a red and orange one, numerator and denominator, so I can cross those out too. And then finally here, I've got an x minus 4 in green and an x minus 4 in orange. So those also will become a phantom 1. Now, as far as I can tell, that's as far as I can simplify this. What am I left with? In the numerator, we have that green 5. And then in the denominator, we have the orange, x minus 5. Now I'm putting that in parentheses just so you can see it really just carries over. Some students don't like that because you don't really have to. Let's see if it'll look. There we go. Oh, crap. But just at the end here, do not, I'm going to say cancel out, which I don't like. Don't make those 5s a phantom 1 because you can't. This is a binomial, okay? But that's done. That's it. And for those of you that are hating this, remember the systems of equations with 3 variables? Yeah. I don't know where I'm going with that. So division of fractions, hopefully you remember, we actually never divide fractions, no matter if they look just like regular numbers or if they're binomials or trinomials. Change the operation into multiplication. Now, some people say the first fraction, you just keep it the same, then you change the operation, then flip the second one. They call it keep, change, flip. I don't care. Just change the operation. Don't use division. Change it to multiplication, and then you see that the second fraction, that's the divisor. I said divisor, but most people, it's just the second part of a division problem, okay? Take the divisor and then flip it. If you want to be a math nerd, then use the word reciprocate. Doesn't matter, yeah. Okay, so just to take us back, because it's so fun, let's take 5/8, and let's say we were to divide it. I'll do by 1/2, something. I don't know if that's easy, but we never divide fractions, not even if they're just numerical like this, and we're definitely not going to if they're binomials or some kind of polynomial. But remember that first fraction, it stays the same as 5/8. Change your operation to multiplication, but that allows you to flip the second fraction into 2/1, and then you could simplify. I'm not doing the prime factorization just for the sake of time, but 2 divided by 2 is 1, 8 divided by 2 is 4, and then you would end up with a final fraction of 5/4 because you just multiply the numerators and denominators, okay? 5 times 1 is 5, 4 times 1 is 4. That would be done. I know it's an improper fraction. I don't really care. I'm just trying to demonstrate we never, ever divide fractions. Change it to multiplication, and then do your simplification. We're looking for any matching factors in numerators and denominators to change into phantom 1. These types, are these polynomials? They are. They're just monomials. Well, maybe they're not polynomials. They're monomials. So, but I do see the division sign between these two fractions. Garbage. I'm going to change it into multiplication, but if I change it into multiplication, I'm going to flip the two fractions, right? So now instead of it being 6 times x to the power 6 over 7y to the 5th, it's now 7y to the 5th over 6x to the 6th. And again, the first fraction doesn't change at all. 10x to the power of 9 over 77y to the power of 8. Now, I'm not going to use prime factorization on the... I will. I will, sorry. All right, so let's focus on one part of the fraction at a time, right? So we still got multiplication there, and it's two fractions. Probably gonna need a longer line. All right, so the 10, that's gonna split up into, I'm gonna make it 2 times 5. And then even the x to the power of 9, I'm gonna do this not to be a jerk or to be facetious, but hopefully it helps you to remember this stuff. But I got 9 x's right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then 77 would split up into 7 times 11, and then would have 8 y's. 1, 2, 3, 4, 5, 6, 7, 8 y's. In the red numerator, we got a 7. That's prime. But then we got 5 y's. 1, 2, 3, 4, 5. And then the denominator, 6 would be 2 times 3, and then 6 x's. 2, 3, 4, 5, 6. Okay? And again, most students don't show all this work. You're welcome to, by the way. It just worries me if you enjoy it. But we're looking for any factors here that I have that I can make phantom ones, right? From numerators and denominators. Just gonna have a lot of matches. So 2 and 2, boom, get rid of those. That's a phantom 1. I'm just starting with the numbers, by the way, and then the 7 and this 7. Okay, that's good. I got a 5, 11, and a 3. I can't really do anything with those. So now I'm gonna move on to letters. I'm gonna start with the x's just because they're in the top left. And so x's, there's 1, there's 1, there's 2, there's 2, there's 3, there's 3, there's 4. There's 4, 5, 5, 6, 6. Now you notice I just made phantom 1 out of 6 of the x's. And then these 6 x's, that's because there was the least number of x's was 6. And then I can see I'm just left with these 3 x's. But I'm going to do the same thing with the y's. So this y, and then this one, and this one, and then this one, and this one, and then this 4th one, and then the 5th one. Okay, so I got 3 y's left over in the denominator. Now I'm going to do this, I'm not going to do it below, but I'm going to write a new fraction here with just whatever's left over. In the numerator, I've got a 5, and then I've got 3 x's. I'm not going to write x times x times x. I'm going to do x to the power of 3. You're going to need those exponents, I believe, on the assignment. Don't write it out expanded form. In the denominator, I do see 11 times 3, which would be 33. And then we have the 3 y's left over. So that's just, again, y to the power of 3. This is as simplified as I can make it. Hopefully I didn't miss anything. But, you know, you can double check. If you've done this work right here, you could double check it. For those of you that remember your cross simplification, you could do that. For those of you that remember your exponent rules, 9 minus 6 would have given you an x to the power of 3. 5 minus 8 is negative 3, but then that just tells you it needs to go in the denominator. Either way. All right. Well, now we see this problem with some division. And since we love division, we're going to enjoy this one. But I'm not even going to factor these yet. Why am I not going to factor them? Because I see a division sign. I don't want that division sign. And I kind of hope you don't either. But if you do, that's fine. I'm going to change that into a multiplication sign, okay? But if I do that, that allows me to then to flip that fraction right there. So having flipped it, let's see if the technology will work. All right, so this is my new problem, which I prefer multiplication. I know we don't prefer fractions though, so just don't let it destroy your life, okay? All right, now that we have that, let's take the numerator and the top left numerator, I should say. And let's go and factor that sucker, okay? It's a binomial, but I don't see that we have any perfect squares in there, so it looks like I'm just going to factor out a greatest common factor of, that leading coefficient is negative 5, so I know I have to factor out a negative, and then I'm going to factor out the 5 as well. So I'm just left with the x in the first term, then negative 20 divided by negative 5, that becomes a positive 4, right? So my new first fraction, we'll show both. But my new numerator is negative 5 times x plus 4. Okay, that was pretty good. Now let's go to the denominator of the same fraction. I'll do it down here. Hopefully that makes a little bit better sense. This is a trinomial, but the leading coefficient is 1, so I'm expecting to create this, to change this into 2 binomials with the first term being x. I just need 2 factors of negative 12 that add up. In this case, that's a negative 1. So it looks like that's going to be negative 4 and positive 3. So minus 4 plus 3. Factoring by grouping still works, but that's as factors as I can see that I can make it. I didn't see any need for any greatest common factors there. So in that denominator, I've got x plus 4 and x plus 3. Okay, let's go to the numerator of that second fraction. X to the power of 2 plus x minus 20. Again, we have a leading coefficient of x, that's 1. So we got an x. We should have some x binomials there. We're going to take that negative 20. We need it to add up to positive 1. That would be 5 and negative 4. So I got a positive 5 and a negative 4. So that's my new numerator there. I got a x plus 5 and an x minus 4. I think I can fit that in hopefully a little better. Yeah, that's better, I think. Now the next denominator. It's kind of similar to that last one, but I see a leading coefficient of 1, so I'm expecting this to be 2 binomials, with the first term being an x. I need 2 factors of 20 that add up to the middle coefficient 9. That would be 5 and 4. So I have an x plus 5 and also an x plus 4. Okay, so writing this in, I have an x plus 5 as that denominator, and then an x plus 4. Now, if you're like me, sometimes you'll make a mistake, and this one says x plus 4, but we just did an x minus 4. You may write that in wrong. Just make sure you go back and check, okay? That was a lot of work right there that we just did. Well, it was some work. If you did factoring by grouping, it was a lot of work. But we're now looking, right? So again, take some time, bask in the glow of what you've just done. But once you're finished with that, then finish simplifying this, okay? So we should end up with one final fraction here. But we need to figure out what we can get rid of. Okay, so anything that matches in the numerators and denominators, let's do it. So the purple x plus 4 right there, I see this blue x plus 4. So those are gone as phantom ones. I also see an x plus 5 here in orange with this x plus 5 in blue. Those are gone as phantom ones. And then the x minus 4 in orange, and I see the x minus 4 in green. Those can become phantom ones. So it looks like I'm just left with, in the numerator, I just have the negative 5. And then in the denominator, again, I'm putting this in parentheses, though you don't have to, an x plus 3. Now that we've seen that with parentheses, though, I'm going to get rid of the parentheses just because it makes me feel better as a math person.
Will you mark those with your
Parentheses there. I'm just not going to because I'm a math nerd, and that's what I'm doing. But some math nerds like the parentheses too, so either way. If you want to be one, feel free to put them in there or don't. Okay, now on this, so some students would say, I'm going beyond the problem because it didn't ask for this. But some students would say, well, what is the domain on this one? Okay, well, let's discuss that. Yeah, so I'm just going to write down the values that don't work. Of course, negative 3 doesn't work, but there were others actually. Remember the denominators on this one? You also had a denominator of, what was that? It was a plus 4, positive 4. And then the other denominator I see, you can't have a negative 5 denominator or a negative 4 one either. And I was looking at these two denominators right here specifically. Those were zeros. That can't happen. That's no good. But in addition, we had this original set right there. And I forget how that works with this one, but it didn't matter because it matched the other ones. So yeah, these 4 values would be restricted from the domain. I put too many commas in there.